decompose fractions with repeating linear factors in the denominators. We want to look at partial fraction decomposition, but the case we're in is where we have at least one linear factor in the denominator with a natural number greater than 1. And that's what we see here. Here's a linear factor x minus 5, but the exponent is a 2. And so what we're going to do is we're going to decompose these particular cases. The way we do it goes something like this. So for this problem, what we're going to do is find our partial fraction decomposition. And for the moment, we don't know that we're in our right case because we haven't factored the denominator. But if I factor the denominator, I factor out an x, and that leaves me with x squared minus 10x plus 25. And then if I factor again, I have x times x minus 5 squared. And please look at x minus 5 squared. This is our case we're in. X minus 5 is a linear factor.
Right.
The squared means it's repeated. It occurs more than once, particularly twice. So what we do is we set up the right side of our partial fraction decomposition to account for every factor. So I'll have a over x. X is to the first degree. A is a constant. You go 1 degree less than what's in the denominator. Then you will have two more terms. You'll have a constant over x minus 5, as well as a constant over x minus 5 squared. And the rationale here is that if I go ahead and add with a common denominator, the x minus 5 squared is necessary, but I also have the x minus 5 there because if I go ahead and add, like I say, that common denominator is still x minus 5 squared. So I'm accounting for every possibility that I could have added these rational expressions to catch my common denominator. Now I'm going to multiply through by the common denominator much like I did before, and my common denominator is x times x minus 5 squared. And when I do that, notice that this particular denominator will cancel with what we have here, and that'll just leave me with 5x squared minus 31x plus 50. And that's equal to, and then my x will cancel with this x here, so a is multiplied by x minus 5 squared. The b, well, this x minus 5 will cancel with one of the x minus 5s, so that'll leave me with b times the x and the x minus 5 still left over. And lastly, the c, the x minus 5 squared, will cancel, and that leaves me with c multiplied by x. That's what we're going to use to solve. So I could multiply the right side through with the distributive property, and then set the coefficients of the squared terms, the x's and the constants, equal, and create this huge system of equations. But there's an easier way, and that way is with the Heaviside method. I'm going to choose a value for x. So I'm going to first choose x to be 5, because that would make two of the factors 0. Right. If this equality holds, it would hold for any value of x. So I'm going to strategically pick that value of x. So I'm going to pick x to be equal to 5. And when I do, I'm going to substitute in. Now you're going to have to get your calculator out because there's going to be a bunch of calculations. X is 5, so what's 5 times 5 squared?
That is 125.
Good. Minus 31 times 5, what's that?
155.
Good. And then plus 50. On the other side, if I substitute in a 5 right here, and right here, now I'm multiplying by 0. So all I have to do is go to the other side of the equal sign, because I'll have a times 0 plus b times 0 plus c times 5. I can solve for c in a heartbeat, can't I?
Yes, you can.
What's the left side? What's 125 minus 155 plus 50?
20.
So now I have 20 is equal to 5c. If I divide both sides by 5, what's c equal to? C is equal to?
4.
I'm going to box it. That's gold for us. Okay. Next, I'm going to pick another value for x. I'm going to pick a value that'll make a factor 0. Well, let me pick x to be 0, because that would eliminate this particular term here, as well as here. So if I let x equal 0, then I have 5 times 0, which is 0, minus 31 times 0, plus 50. And that's equal to a times 0 minus 5 squared, and then plus b times 0, and then plus c times 0. I can do this calculation pretty quick. What's the left side of the equality?
50.
And the right side?
It would be a times negative 5 squared, so 25.
So what would the right side of the equality be?
25a.
Beautiful. And then if you divide both sides by 25, what's a equal to?
2.
Beautiful. Now if I have a and c, all I need is b. So if all I need is b, then I'm going to go ahead and pick any value for x. Now for the last value of x I'll choose x to be 1. I can choose x to be any number, but I know a and I know c. So if I substitute in a is 2 and c is 4, all I need to do is find b. So if x is 1, I have 5 times 1 squared, which is 5, minus 31 times 1, which is
31.
plus 50.
Right.
And on the right side, I have a, and I know what a is.
A is 2.
So I have 2 times 1 minus 5 squared. And then I have b, which I still don't know, times 1 minus 5, plus c, and I know what c is. C is what? C is
4.
and then I have 4 times 1. Well, I can do this calculation pretty quick. 55 minus 31 is what? It's
24.
okay, so I have 24 is equal to, then I have 2 times, really, 16, right?
Yes.
And that'd be what? That'd be
32.
32 minus, I want to say minus 4b. 1 time minus 5 is negative 4, negative 4b, plus 4. So it looks like I have 24 is equal to what? Is equal to
36 minus 4b.
beautiful. And so negative 4b is what? Negative 4b is, I want to say negative 12.
Right.
What's b equal to? b is equal to
3.
3. And there I have it. I have a, b, and c. So when I write the partial fraction decomposition, all I do is substitute those values in. And I end up with a, which is 2, over x, plus b, which is 3, over x minus 5, and then lastly, plus c, which is 4, all over x minus 5 squared. Thank you.